Hello everyone, here's Mr. Scott again with another one of my videos. This one is about how to solve linear equations. So what does this word linear mean? Well, it means if we were to draw a graph of the equation, we'd get a straight line. And also, when we're writing it down, we can see x to the power 1, which we normally just write as x. We won't see x squared, we won't see x cubed, we won't see x to the power minus 3, anything like that. We'll just see x. Let's have a look at an example. Solve 4x, add 3 equals 15. So let's make sure we understand the question. First of all, what does it mean when we say solve? Well, it means to find out what number x is. Okay, so we can replace x by a number. And what does 4x add 3 equal 15 mean? Well, it means that there's a number that you don't know, I know, but you don't. And when I times it by 4 and add on 3, I get 15. So I like to translate these equations into English to make sure that I understand what they say. How do you solve an equation? Well, you do the opposite, also known as the inverse, of each operation, and you do them in reverse order. What is an operation? Well, they're these guys. Add and subtract, times and divide. All right. Now, I've made quite a lot of notes there before even getting to start to attempt to solve this question, to answer this question. And what I'm doing by having the questions here and covered up answers here is I'm effectively creating a set of flashcards as I'm doing the work in the first place. So when it comes to revising, I've done a lot of the hard work already. So here's the question then. Solve 4x add 3 equals 15. So I know that there's a number that when I multiply it by 4 and then add on 3, I get 15. So what do? I work in reverse order. What was the last thing that happened? It was this add on 3. So I need to get rid of that. And it's gone, look. It's no longer on this side of the equation. How did I do that? Well, I took 3 away from this side of the equation. So what do now? I do the same thing on the other side. So I keep this idea of doing the same thing to both sides of the equation. Now that's really important. I know some people will just say, oh, it's 15 take away 3. And yeah, that works nicely with these simple equations. But what I want to be able to do is to lay down some ways of thinking that are going to help me when I do some more complicated equations. Right, I've now got another equation written here, 4x equals 12. I'd prefer that to be in blue. And again, I translate it. What does it mean? There's a number that when I times it by 4, I get 12. I don't want it multiplied by 4. So I just write down the number as it is, just x. I've got rid of the times by 4. How do I do that? I do the inverse of times by 4. I divide by 4 on this side, which means I also divide by 4 on this side. And that gives me 3. X equals 3. My number is 3. My process in going through this all the way is to make this side of the equation simpler. At every point, I'm removing something from this side of the equation until I'm left just with x. What happens on this side is entirely a result of what I've done over here. So I'm not focusing on this side at all. I'm focusing on this side. This side sorts itself out. Okay, focus on the more difficult side. All right. Now, what I like to do is to check that this is right, because x is no longer some mystery number, it's the number 3. So I can come back up to here and substitute in. This is now 4 times 3, which is 12, and add 3 does get me 15. So I know that's right. So the wonderful thing about these kind of questions is in an exam, I'm not worried about that question. I don't need to think, wait until I get the answers back. Have I got it right or not? I know I've got it right. Or, not quite as good, I know I've got it wrong and I need to have another look at it. All right, your turn. Try this question. Solve 4x add 9 equals 21. Pause the video while you have a go at it and then press play again, and I'll see you on the other side and we'll work on it together. Okay, let's look at this one then. What does this say? It says a number times by 4 and add 9 makes 21. What was the last thing that happened in creating it? It was add 9. So let's get rid of add 9 from this side. Notice I'm working on this side. How did I get rid of add 9? I did the inverse of add 9. I took away 9 from this side. And that means that I'll do the same thing on the other side. 4x is 12. What does this say? It says a number times by 4 is 12. I don't want the number times by 4. Get the number on its own. How did I get rid of that times by 4? By the inverse of times by 4, which is to divide by 4 on this side. And so I divide by 4 on this side. And I get, again, that my number is 3. Let's check that. 4 times 3 is 12. Add the 9 gives me 21. I know it's right, and I can stop. All right. A little bit of a bonus here for you. What does this say? My number times by 4 and take away 3 is 15. What's the last thing that happened? Take away 3. So get rid of take away 3. It's gone. How do you get rid of take away 3? You do the inverse to take away 3. Let's add 3. Do it on both sides to maintain the balance. And I get 18. What does this say? It says my number times by 4 is 18. All right, I don't want my number times by 4, so get my number on its own. How do I do that? I do the inverse to times by 4. I divide by 4. I divide by 4 on this side, and so I divide by 4 on this side. And this is where some of you that are focusing on this purely numerically, concentrating on this side, might get stuck because you think 18 doesn't divide by 4. But those of us who are focusing on the algebraic side, the more complicated side, aren't so worried about that. And here's a really nice thing. I can write 18 divided by 4 like that. 18 quarters. Mathematicians are quite happy with that. There's a good chance that would get full marks in the exam, and I could leave it like that. Okay, good chance that that's the case. But you might want to go on a little bit further. So you might say, okay, what is 18 divided by 4? Well, 4s do go into 18. They go 4 times with 2 left over. That still needs dividing by 4. 4 and 2 quarters. 4 and 2 divided by 4. 4 and 2 quarters. You might want to simplify that. 2 quarters is a half, so 4 and a half. You might even want to write it as a decimal. Notice that's my last choice. I would stop here. Yeah, maybe go on as far as here. I wouldn't write it as a decimal unless the question asked me to. No need for it. Right, so how are we going to summarise that? Well, first of all, translate the equation into English. I wrote it down. You don't have to do that. but do make sure you're clear in your own mind what the equation means. It's a number times by something, add or subtract something else to make another number. All right. When you know what's happened, so in my case, times by 4 and then add 3, you know what has happened, you know what the operations are, times by 4 and add 3, so you can do them in reverse order. The add 3 needs getting rid of first, and then the times by 4. How do you do that? You do the inverse, the opposite. So instead of add 3, take away 3. Instead of times by 4, divide by 4. And that's it. I'm going to stop there. You have got some questions? Let me know how you get on.